Hey everybody, welcome back to Vibe Code Camp. I'm Paul Wakeham. In this video, we're going to go over a lot, but a lot of really exciting stuff. We're going to go over a lot of diagrams. As you can see, I have quite a few diagrams here for the different phases of the plan that I put together and that I executed for this video. But I'm going to go over as much code as I think is necessary, but I'm not going to go over a lot of code. And that's because I think that the diagrams and the explanations that I'm going to give here will give you enough to understand how to plan and execute and talk to Claude Code or Cursor or any other AI that helps you write code. It'll help you talk to those AIs in such a way that the outcome you're looking for will be produced without you having to understand the lines of code that were written. And just so we're all on the same page, I don't even understand all of the lines of code that were written, but I do understand this high-level picture of what was done and why each step was done, and that's what I hope to get across here in this video. So a couple major things we're going to talk about. First is Supabase and why we're going to be using Supabase. So Supabase is our database. That's where our user information is going to be stored inside of a user profile table or model, which we'll get to. And then we're going to talk about the messages and conversation tables. So Supabase you can think of as the way that all of this data that is created by our application is stored, and it gives our application an easy way to access that data. You can think of it like, how does your application know that you've already signed up? Or how does the application know what your previous conversations were? That isn't stored in the front end that you interact with, and it's not stored in the back end, which is the brain of the application. Rather, it's stored inside of Supabase. Now, in addition to Supabase acting as this store of data as a database, we also set up Supabase, and I'll go over all of this, to be the authentication engine for us. Now, authentication is a fancy word to say, do you have permission to do the things that you want to do? Do you have permission to send another message in a previous conversation? Do you have permission to log into Paul Wakeham's account? If you don't, then you can't do it. So authentication is handled by Supabase, and it really says what are and are you not allowed to do. And I set up all of that over the past couple weeks, and I'm going to go over all of that in this video. Now, last thing, I have been working on this project as much as I possibly can. This whole process will not take you a couple weeks to set up. I've just had a couple other exciting things on my plate, and I haven't had enough time to really focus hard on this project. But I've got it done. And the exciting thing about this video, once I get through all the diagrams and some of the code, is that the back end of the application is ready to go. We can now start working on the front end of the application, meaning we can start working on what does it look like? What do the buttons look like? Whenever you click a button, what happens and what does that mean? And really making the visual interface. That will be in the next couple videos. So let's dive into authentication and what we did to finish up the back end for our AI scheduler application. So if you remember from last video, we have this set up here where a user sends a message via the front end, even though we don't have a front end built right now. And the user's message goes to an orchestrator agent. The orchestrator agent then calls sub-agents that we don't have direct access to. Those sub-agents use Composio to interact with the user's Google Calendar and the Google Maps API that then report information back to the orchestrator agent, and the orchestrator agent sends that information back to the user via the front end, and right now it's just happening inside of our terminal. So in order for all of this to happen in a production application, something that I would feel comfortable putting on the Apple App Store or the Google Play Store, is you have to have one, persistence, meaning that you can go back and you can continue conversations that you've had previously, or even inside of a conversation, the AI will know what was said 1, 2, or 10, or 50 messages ago. That's called persistence. And for that, we need a database. But then also we need authentication and the security related to authentication. First things first, before we jump into the database creation, we're going to jump into these diagrams here that go over a high-level overview of how authentication is set up inside of our application using Supabase. So like I said, Supabase handles all of the data, but it also handles giving you the access tokens or keys that allow you to access the data that is stored inside of Supabase. So I broke down this entire process into a planning document, just like I normally do, using regular context engineering principles. And the first phase was really just a setting up of the environment and making sure that the correct things were installed. But phases 2 and 3 were setting up a modern auth architecture or authentication architecture. So let me walk you through what was done here. We're going to go and follow this bluish purple line here first. So when a user signs into the application, I'm going to delete this for now, this little token. When the user signs into the application, there is no token yet. You can think of a token as, hey, this user is legitimate. They have the ability to act inside of the application. They have the ability to do things inside of the application. So when they sign in, what happens is the user's information is sent to Supabase. And we created a table. It's also called a model inside of Django. Remember, Django manages our backend, and our backend talks to Supabase as our database. So we created a table called user profile. That's also called a model. Model is a Django term. A table is a Supabase term. They are the same thing for the sake of this video. So we created a user profile table or model, and we set up authentication inside of Supabase. Now, when the user signs in, the trigger of the user wants to sign in is sent to Supabase, and it checks the user profile model. And if the user exists, what Supabase does is it sends this what's called a JWT token. You can think of that as like stamp or a pass that is taken and given to the user's application on the front end that says, hey, Paul exists, or this user exists, and they are allowed to access the things that are associated with them inside of the other database tables, which we will get to. Other database tables will be things like your conversations and the messages inside of those conversations. So Supabase handles sending the front end this key or token or a stamp that says, hey, this user is allowed to do things inside of the application. Now the user is authenticated now that they have this JWT token. And that is all handled by Supabase. Now let's continue that authentication flow. Now the user is sending a message now that they're signed in. Now that they're signed in, they have this JWT authentication token, and that authentication token is sent with the user's message here. And it's sent to an authentication verification layer in the back end of our application that I told Claude Code, or that Claude Code knew we needed to build. And so what this does is it goes to Supabase and it retrieves what's called a public key. And this is some cryptography stuff that is probably too in the weeds for me and even for this video, but the public key essentially verifies that this token that is coming along with the user's message is legitimate and is associated with this user. So Django, the backend, gets the public key. The public key says, yes, this user exists and their authentication token is legitimate and they're allowed to do things. Okay, they're allowed to do is they're then allowed, because Django lets them through, they're allowed to send the message to the AI agents. The AI agents then can send their response to the backend. And I have this little lightning bolt here because this process of taking the user's authentication token, getting the public key from Supabase, checking to make sure that everything is okay, this happens in about 50 milliseconds, sometimes even faster. So super fast. That's 5% of 1 second. So it happens super quick and it's all orchestrated by Django. Okay. Now we understand how authentication works. Essentially, the user can't do anything unless they have this token, which they get from signing in. And then once their token is verified, they're allowed to do things inside of the application, like send messages, which also entails accessing their prior conversation or chat history. Okay, move on. Now, let's go down to what was phase 6 of the plan. Now, we skipped phases 4 and 5 of the plan because phase 4 and 5 actually assumed when the plan was written that this entire authentication process that I've walked you through would be handled by Django, not by Supabase. But I read through the plan and I came to the realization that the plan was written incorrectly. So I went back to Claude Code and I said, wait, we need to do authentication with Supabase, not with Django. So then it rewrote phases 2 and 3 of the plan, and then we executed phases 2 and 3, totally did away with phases 4 and 5. So phase 4 and 5 inside our planning document, I had Claude Code update it. They're marked with red X emojis because they were never done, because again, they assumed that we would use Django for authentication instead of Supabase, which we want to use because it's much faster, it's modern, and it's much more secure. Okay, now let's go to phase 6. So phase 6 is where we set up all of the different database models and tables to have conversation persistence, meaning you can go and you can access the previous conversations that you've had, and you can access the previous messages that you've sent, and we can make sure that those are sent to the AI so the AI knows what was previously said. So here, in this case, user sends a message. We have their authentication JWT token. The JWT token is sent to Supabase, and what's really here in between is this layer of Django checking, but that only happens once. So it's sent, the user's message is sent with the JWT token, and then it's sent through the database, through some things that we'll get to in the next step. And the database says, here's a new user message, store it in the database. But what is actually sent to the AI, and this is very important, is the new user message, which is stored in the database, and the chat history is sent to the AI. So how is that done? So we have the user's profile, which is used for authentication, and the user's profile is connected to a new table down here called conversations. It's connected to the conversations table through something called a foreign key. Essentially, inside of the table that is the user's profile, there's a column of all of the conversations that they have. And inside of that column of all the conversations is the identification number, or the UUID, for each of the conversations the user has. Then inside of the conversation table, there's all of the conversations, all of the chats that all of the users have had. But then inside of the conversations, there's links to messages. That's also linked through a foreign key. So whenever the user sends their message, we have all their user information. We have their conversation that is sent, that data is sent along with the user's message. And then we have all of the messages inside of that conversation, all linked together with foreign keys, essentially pointing back to each other. With those foreign keys, we're able to send not only the newly created message by the user that was stored in the database, but we're also able to access the sequential order of the prior messages associated with this conversation. So then this way, the AI not only receives the new user message, but it also receives the historical messages that were sent in that conversation. Now, I said this is super important. I said that because whenever an AI generates a response, that's ChatGPT or the orchestrator agent or any AI that you interact with, when it generates a response, what it's doing is it's actually generating a response based on all of the text contained in the previous messages. If I showed you the code for this, you would literally see an array that is a list of objects that is the user message and then the text associated with the user message, assistant message, and the text associated with the assistant message. And you would see those in a big long list. That entire chunk of information is sent to the AI every time you send a new message, and your new message is appended or attached to that array. That gives the AI an understanding of all of the things that have been said up until that point in the conversation. This is how all AIs work. Now, As a brief side note, the messages that have been sent previously, they're actually cached, which means they're not counted as tokens against your quota. That's just a way for the whole chatbot system or AI system to be much more efficient, but I won't go deeper into that. It's essentially a way for you to make sure, or a way for the AI companies to make sure that you aren't spending too much money or using too many credits to interact with the AIs. But nonetheless, the AI receives all of your messages and your new message and then generates a response to it. So it looks at everything you've said and then generates a response. So to make sure that the AI that we've created, this orchestrator agent, is aware of what has been said, we need to store those prior messages, that chat history somewhere, and we store that in our conversations database, and the messages inside of that conversation are linked to that, and they're linked to the user. So we send all of that to the AI. The AI then uses its subagents that have access to its tools via Composio to generate a response. Now, that response, so the AI knows what it said whenever you sent the prior message, that response is also sent to Supabase, and it is stored inside of a message inside the conversation model. After it's stored inside the model, it's then sent back to the user, so the user sees a message that takes into account all of the prior messages and the newest message that the user sent. I hope all of that makes sense. It's really a fascinating way that AI works, with the chat history and the newest message being appended to it, and all of that being sent to the AI so that we can get a response from the AI that is relevant and within the context of the conversation and the previous messages that have been sent. Now, before I go on to phase 7 and what we did there, I want to explain how these models were created. Now, remember, the front end talks to the back end and the back end talks to the database. So in order for us to create these models, I didn't go into my Supabase account and say, I want to create this table with these headings or these, and I didn't say I want to create the conversations table with these columns and type all that in manually. What I did, and this is one of the beautiful parts of using Django, is I said to Claude Code, I want you to create the database tables for us to have conversation persistence and proper authentication inside of Supabase. And what it did was it wrote some code inside of a special file called a migration inside of my project. And I'll show that to you real quick. So we're here inside of Cursor, and you can see we're inside of the AI Scheduler VCC project, and then inside of backend, and then inside of the scheduler app, and then inside of there's this directory or folder called migrations. And inside of the migrations folder, we currently have 3 migrations. And all of this code here is the creation of the user profile table and the fields or columns of that table. You can think of it like the creation of an Excel table or a Google Sheets table. And then another table was created called planning sessions that we actually got rid of here in another migration because we ended up not needing the planning session. So the actual tables from our diagram over here were created via these migrations. Now, because the settings inside of our Django project connect our backend to Supabase as our database, these tables were created inside of Supabase. I can go inside of my Supabase and I can see these tables with these columns were created. For example, the conversation table was created and it has a title of the conversation, the agent session ID, if it's active, when the last message was sent, when it was created, when it was updated at, so on and so forth. And it has this user profile, which is the foreign key connecting it to the user profile table that was created in the prior migration 001_initial. So I'm telling you all of this so that tables are created via these files called migrations, but they're also updated via these migrations. Let's say for some reason we wanted to send photos inside of our messages with our AI, and we wanted to store the URL for those photos that are sent to the AI. We would need to create a migration that adds a photo URL to our messages model or our messages table. What we would do is we would tell Claude Code, hey, I want to add a message column that allows me to send URLs to photos, and I need to store that in the database. I need you to create a migration for that. And it would come in and it would write this code that would then update the table. So I feel like this is an extremely important part of the process. So I'm going to go just a little bit deeper. So the migration code, what it's actually doing is it's taking all of this code here, and when it's sent to Supabase, what Django is doing is it's actually writing another language of code called SQL. Now, you can see each of these migrations is a .py file or a Python file because Django is a Python library. But whenever these migrations are executed and they're sent to Supabase to update or create our tables, what Supabase actually receives is a bunch of SQL, which is a different language that allows you to interact with databases. So rather than us having to manually create the tables, or rather than us having to write the SQL to create, update, manipulate, and do things with our database tables, we write migrations in Python code, specifically inside of the migrations folder inside of a Django project, that then are translated to SQL, which actually show up as changes to the tables in our database. Now, I'll show you real quick what the database looks like after these migrations were applied. So here we are inside of Supabase, and specifically we're inside the VCC project, the AI scheduler-VCC-dev. That means that we're inside the development environment inside of our database. And we can see we're inside of the conversations table. Now, you can see the conversation ID, title, agent session ID, is active, last message at, created at, so on and so forth. Those exactly match what we have over here inside of our conversation table that was created with this 0002 underscore conversation underscore message. You get the point, this migration. So this migration was the thing that was sent to Supabase and the table was created. So just to say it again, the migrations are the things that actually make the tables inside of Supabase. Now, a little bit more code. The models themselves and how they look and what is the makeup of the model and what each field is capable of and how they all connect together with foreign keys, that's all actually dictated inside of a models.py file. So the path to this models.py file is backend inside the Django scheduler app that we created. And then inside of there, we're just at the root level of the scheduler app, the base level of the scheduler app inside the models file. And we can see, if I move myself here, that we have a user profile model and then a description of what each of the fields is, along with a comment that code wrote for us. And then if we scroll down, we have a conversations model. And if we scroll down from there, we have a messages model and all of the fields inside the messages model. So whenever you need to make manipulations to the type of fields, you make them inside of the models file first, and then to apply them to the Supabase database tables or any database table, you actually do that via migrations. I hope all of that makes sense. Let's jump back into the diagrams I created. So here in phase 6, we went over how the database tables were created and how they're all connected to each other with the models.py file and the migrations and the various migration files that are numbered, in this case right now, just 1 to 3. Okay, now let's move on to phase 7. So phase 7 is where things start to get a little bit more technical, so bear with me. In phase 7, we create this thing called an API. So you might be familiar if you have any programming experience. You've watched any of these vibe coding videos like mine. An API is just a bunch of URLs that you can send data to. They're just a bunch of links that you can send data to. And if you're using the Google Maps API, or you're using the, I don't know, let's say you're using the Open Router API, you send a bunch of data through the internet to a specific link. And then that specific link does a bunch of stuff behind the scenes. It sets off a bunch of processes, and then it sends you back the result of those processes. That is called a request. Specifically, that's called a post request. So you send information to a URL, to a link inside of an API. The API sets off a bunch of processes with the data that you sent, and then it sends you back, or it does something with the result of all those processes. The way that a front end of an application communicates with the back end of an application is, for all intents and purposes, identical to what I just described. When you press a button on the front end of an application, that data that is associated with, let's say, sending a message is sent to the API that is private inside the back end of our application. And it goes through the entire authentication workflow to make sure that the token, as you can see here, that the token is with the user's message and the user has access to the API. And our API is connected to URLs, views, and services, which I'll walk through next. But I want to make sure that I'm clear that an API can be a public API that we can send information to, send data to, and then get something back, like the Open Router or OpenAI API. But it's also how the front end of an application, the buttons, the things that you actually see, how they send information to the back end, have it processed, and then have that processed information sent back so that the user sees something update on their computer. So Django, being as great as it is, gives us a really easy way to create those back-end APIs. And those APIs are created through URLs, views, and then services. So URLs are literally the link that you say when the user clicks the send message button on the front end, it sends the data that's associated with it to a URL on the back end. You're literally sending the data to a link, just like facebook.com/user profile. We're creating those links or URLs. So I had Claude Code create the API with URLs that do all of the things that we need the front end to be capable of, like viewing the user's prior messages, sending a message, updating their profile, all of the things that the user wants to be able to click around and actually do on the front end. They need to be connected to the brain, and the way they're connected to the brain is via the API and via the URLs. Now, when the URL inside of our backend API receives the user's data, in this case, the user's message, with the token that says they're authenticated, they're allowed to do this action, the URL then takes that data and sends it to a view. Now, this whole process of splitting things up is really important for all programming. It's called a separation of concerns. I'm telling you that because if you're programming with Claude Code, or you're trying to get Claude Code to do things for you and write really neat code, you want to tell it to have proper separation of concerns. In our case here, that means that the URL file only has URLs inside of it. And then the URLs are referenced by the views, and the views have a bunch of functions that are imported from the services. So what does that mean in practice? That means that when the user's message with their authentication token is sent to the API, it's sent to a specific URL. That specific URL triggers a view, and then the view actually triggers a bunch of functions that are written in separate files called service files. I'll show you exactly what that looks like on the back end inside the code, but I want to make sure this is super clear. You don't want to put what's called the business logic or the service logic inside of the views files. In other words, you don't want the machinery that does the stuff, that manipulates the data, that generates a response by the AI. You don't want that to be in the views. You want that to be separated, separation of concerns, into service files that are imported into the view or into the views that are callable by URLs. That separation, I guarantee it will make your code easier for you or a developer to read, and it will make it easier for Claude Code and any AI to interact with. So let's jump back into Cursor and I'll show you exactly what this looks like. Okay, here of Cursor, we're inside of the AI Scheduler VCC, inside of backend, inside of the Scheduler app, and then here we can see we have a urls.py file and a views file. Now let's go to URLs. You can see it's relatively short. There's the paths to the URLs, and you can see that Claude Code added comments, that is user profile endpoints. Those are URLs or links that can receive information about the user and their profile and allow things to happen whenever those are called and data is sent to them, specifically about the user's profile. Like you can see, the name of this is user profile update. So this is the URL that information will be sent to when the user wants to update their profile. And then the same thing here for connections, conversations, and messages. These are the URLs that are receiving the data from the front end. And then from the URLs, the views actually take all of that information and then they call different functions. The easiest way to see this is by looking here inside of the imports. So we have this serializer. The serializers, you can think of them like service. We can see that there are many different functions that are imported from the serializers file. And then down here, we can see that from scheduler.services.userService, these functions are imported. Now we can see down here from scheduler.services.messageServices, message service, and from services.agentIntegrationService, these functions are imported. So the actual functions that do stuff with the information, those are being written inside of serializer and service files. For all intents and purposes, back here on our diagram, you can think of serializer and service files as being in this blue bucket here. And they're not written inside of the views file. Some people make the mistake of writing the actual logic that does something with the data inside of the views file. That will hurt your code because your views file will get even longer than the roughly 400 lines of code that I have right here. You want the views, like for here, let's take this authenticated view and the update user profile. This update user profile view, it imports, let's see, it imports and then calls this update user time zone if you want to update the user's time zone. So that function is actually defined elsewhere inside of a service file. So let's go find where that service file is. Update user time zone is located inside of services, inside of scheduler, inside the services folder, inside of the user service service. Let's go find that specifically. Services, and then the user service file. Here inside of this file, we can find the, let's search for it, update user time zone. So again, we're here inside of the backend, inside the scheduler app, inside the services folder, inside of the user services.py file, looking at the function that updates the user's time zone. That function specifically is defined here, but it is imported into the view and callable by the view, but the view is called by the URL. So we have the URL, the view, and the view calls the service file. In this case, it's calling the function inside of the service file. I hope all of this makes sense. So that's our API layer. Again, the API layer is the layer that the front end actually sends information to and then gets information back from. So we'll take the example a little bit farther here. The user sends their message, the API calls the specific URL, which then calls the view, which has imported functions from the service files. Those service file functions do things, and then let's say in this case, it's a user message function inside of a service file. That user message is sent to the database first by the functions inside the service files, and the database stores it. It's then sent by the service file, which is connected to the view, which is connected to the URL, to the orchestrator agent. The orchestrator agent responds based on the user's new message and the chat history that was sent through the chain of events over here, like I've gone through. The AI responds based on all that information that is sent to it. That is stored in the database, and then that is sent back to the front end. So we create this API as a way for the front end to interact with, send data to, and receive data back from the back end. Again, without this, the front end wouldn't have any way to send and receive information, or send information to the back end and have something happen and then have that information sent back. This is like the way that the brain of the back end is opened up to the rest of the world, or opened up to the front end for the front end to have access to. Now, just to finish the explanation here, what companies that offer APIs do, just as a simple example, whenever OpenAI has an API, what they do is they create all of these different steps. Maybe they don't use Django, maybe they use a different service to create their API. But the URLs that they create, those are accessible and documented inside of the API documentation, so that anybody's front end or back end can call those API endpoints and get the information back from them. Again, in our case, with our URLs, views, and services inside of our API and inside of our backend, no one else has access to them except for our users. It's not an open API. Okay, last phases. Phase 8 was super quick. We just copied the migrations that were done to the development database to the production database, meaning that the user profile table exists in both the development database and the production database. Same thing for the conversations table or model, and same thing for the message table or model. So that was super quick and easy. It only took about 3 minutes for me to ask Claude Code to make sure that everything was mirrored inside of the production database that already existed inside of the development database. Okay, now phase 9, what we did was we handled what happens whenever a user signs up. And whenever a user signs up, we want to make sure that the user sign up process includes getting access to their Google Calendar. And that requires us to interface with Composio. So if you remember from prior videos, Composio handles the interaction with Google Calendar and the Google Maps API. So I'm going to walk you through this. This gets pretty in the weeds, so I'll try to do the best job I can to make this simple. So the user signs up, and through their sign up process, they will hit a process that says connect your account to your Google Calendar account. We need authorization and authentication into your Google Calendar account. That is all handled by Composio. So Composio took that call and generated a Google authentication screen. I'm sure you've seen these many times. You just say, do you trust this application to have access to all of your stuff inside of your Gmail account, or inside of your work account that is managed by Gmail? So Composio generates this screen. You say allow. In this case, you're giving Composio and our AI scheduler app access to your Google Calendar. So you check off the boxes that say, I agree to give you access to my Google Calendar. Then that information is sent back to Composio. That is this token that says Paul has authorized us access to his Google Calendar. Composio then stores that authorization token inside of the Supabase database. Now, this way, anytime you interact with an AI agent inside of the AI scheduler application, the AI inside of the application will know that it has access via Composio to your Google Calendar, because the token that says Paul has given me authorization to interact with his Google Calendar is stored inside of the database. That authorization persists inside of the database, but it is all generated and originated by Composio. Throughout this process of setting up this Composio step, we actually had a couple hiccups because I was developing locally and I didn't have a public URL for this Google OAuth screen to redirect me back to. So we had to set up something slightly, we had to set up like a local on my computer. Claude Code knew how to do all of it. I just kept pushing against Claude Code, saying, I want to make sure that a new user has the ability to sign in and give Google and Composio access to their Google Calendar. And it did it perfectly fine. It works really well. And the last thing I want to go over here is with all of these steps completed, I ran a couple tests and we can see inside of the OpenAI backend that the messages were sent and received from our API endpoints, and the AI had knowledge of the prior messages sent in the conversation, and the AI had proper access to a brand new user's Google Calendar via Composio. Again, all of that was really orchestrated by Supabase and then setting up the models to interact with Supabase via our Django backend, and then using Supabase for authentication. So I know that's a lot. I know we didn't dive into the code very much, but like I said at the beginning of this video, I personally don't understand the code very much, but I do understand this high level information well enough to be able to communicate what I want to Claude Code. And I hope that this video allows you to do the same thing so that you can set up Django and Supabase and Composio authentication inside of your own application. I just want to say one last thing here, that everything we've done up until this point, this could be used for an AI agent workflow inside of a web app or inside of a mobile app. This API that we set up here is callable by a front end built inside of a mobile app or a front end built inside of a website, a web app. So the next videos will be all about building the front end that communicates with this API and goes through all of the processes that we've gone over in this video so far. But everything we've built could be used for a web app that does all of the same stuff, like a user communicating with an AI that allows it to interact with their Google Calendar. That could all be done on a mobile app or a web app. I hope all that makes sense. I know we went over a lot of information. Rewinding back in this video to find how I talked to Claude Code and how I described the models and the tables and the APIs and the views and Composio sending the authentication tokens and the JWT token. Rewind and go find all of that stuff so that you know how to communicate with Claude Code to set all of this up as well. I hope all that makes sense. If you have any questions, please reach out to me. Thanks so much for watching, and I'll see you in the next video.